Okay, hi guys. Today I want to talk about trigonometric functions. This is chapter 10 in the AdMath syllabus. Okay, so in this topic we're gonna go from the absolute basics to the introduction of triangles, the definition of all the terms used in trigonometry, and we're gonna gradually build to solving trigonometric equations, the applications of trigonometry and all that. So just to start with the absolute basics of trigonometry, there are a few terms that you have to understand. So in trigonometry, we usually deal with right angle triangles, okay? To deal with trigonometric ratios, sine, cosine, tangent, you might have heard of them. So to understand that, we have to understand these three terms. So there is the opposite, the adjacent, and the hypotenuse. So now to start with the hypotenuse is the side that is opposite to the right angle. So if the right angle exists over there, the side exactly opposite to it is the hypotenuse. The side opposite to the angle we're working with, which is theta, which is placed here. The side opposite to the theta is called the opposite. Opposite, and the side adjacent to it, which is on the same line as the angle theta, is called the adjacent. So the three sides in a right angle triangle for trigonometric use is opposite, adjacent, and hypotenuse. See, the position of the opposite and the adjacent can change depending on where the angle theta is placed. This becomes the opposite and that becomes the adjacent, because the position of the angle theta has changed. So depending on where the angle theta is in the triangle, the opposite and the adjacent will change, but the hypotenuse won't change because the right angle stays in the same place. It cannot be moved. Okay, now for the introduction of the trigonometric functions that we have at hand. Okay, so now I'm going to draw another right angle triangle over here. Okay, let's make this the right angle. Side O, P, and edge Q. Okay, so now we're assuming theta is positioned over here. Okay, so as I've said before, this becomes the opposite. OPP, this becomes the adjacent, and the angle opposite to the right angle is the hypotenuse. Let's call it hypo. Okay, so now we have three functions in trigonometry. I'm going to write the full form here. We have sine, we have cosine, and we have tangent. Okay, so the three angles, the three trigonometric functions for angle theta, for in terms of angle theta, is represented such that sine is the opposite over the hypotenuse. So sine basically equals the opposite, PQ over OP. So the opposite over the hypotenuse. Now cosine is the adjacent. Cosine is the adjacent over the hypotenuse. Okay, so the adjacent to angle theta is OP. Okay, so equals OP over the hypotenuse is PQ, and the tangent is the opposite over the adjacent. See, the hypotenuse is not involved in this trigonometric function, so tangent is PQ over OP. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now let's apply what we've just learned. Okay, so given a right angle triangle ABC, side ABC, okay, we have BC is 2 units, we have AB is 1 unit. So now we have to find all three trigonometric ratios of angle A over here. So we have to find sine of A, the sine of A. See, sine, S-I-N-E, is written as S-I-N for short form, and cosine of A, C-O-S, and tangent is written just as tan, tan of A. Okay, so now let's write down the formulas. Opposite over hypo, adjacent over hypo, and opposite over adjacent. We first have to calculate the hypotenuse because we need the value of the hypotenuse AC for the calculation of sine and cosine. So to find the hypotenuse, we use the Pythagoras theorem, which you already know. So AC square is equal to AB square plus BC square. So AC square is equal to 1 square plus 2 square equals 5. AC square equals 5. AC equals the square root of 5. And it can only be positive. There can't be any negative values in the Pythagoras theorem because length is purely a modulus value. So the sine of A from with respect to this angle A, the opposite of A is 2 and the hypotenuse of this triangle is square root of 5. So 2 over square root of 5. It is acceptable to present the answer as 2 over square root of 5, but if you want to rationalize it further, you can also write it as 2 square root 5 over 5 by multiplying square root of 5 up and down. Rationalization. So adjacent of, the cosine of A is the adjacent over the hypotenuse. The adjacent of the angle A is 1 and the hypotenuse is square root of 5, or you can also write it as square root of 5 over 5. For the tangent is just opposite of the adjacent. Hypotenuse is not used. So the tangent of the angle A is 2 over 1, making it 2. Okay, now before I conclude this video, I just want to remind you all of the 3 things you must have learned from this video. The terms opposite, adjacent, and hypotenuse. How to define them based on the position of angle theta. Number 2, right angle triangle. Parts of the right angle triangle. Number 3, definition of sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. So if you can understand these 3 things, so the opposite, adjacent, hypotenuse, what they mean, the right angle triangle, the parts of the right angle triangle based on the opposite, adjacent, and hypotenuse, and how to identify them. And number 3, the definition of the 3 basic trigonometric functions, which is sine, cosine, and tangent, and how they are related to the positions of the opposite, adjacent, and hypotenuse. So if you can understand these 3 things from this close to 10-minute video, you will be fine for the next one. In the next one, we will be looking deeper into the trigonometric ratios of special angles. So the special angles in the scale that we have to look at, some things we can remember, how it all ties in. Okay, so thank you. Please look forward to the next one. Thank you.